Hi friends, so we're going to go over a proof of the Pythagorean theorem and how we can prove that a squared plus b squared will always be equal to c squared. So you can see here that I have a figure of two squares, a blue and a pink, and I've labeled their side lengths, and I've intentionally made those side lengths be variables rather than actual numbers because I want you to see that you could use this same proof on any side length for your squares. So if we look at the area of the blue square, you can see that the side lengths are A and A. So to find our area, side times side, A times A, is A squared. For our pink square, our side lengths are B and B. So B times B gives us an area of B squared. So for this figure, my blue square plus my pink square would give us an area of A squared plus B squared. Okay, and I want to make it really clear that no matter what, the area for our figure is not going to change. We're always going to be dealing with this amount of space that contains both our blue square and our pink square. So now what I'm going to do is I'm going to draw some triangles on our figure. So I'm going to take this and I'm going to make a mark on this by taking this and flipping it over here. And the mark that I draw is going to be the same length as the side of our pink square. So our pink square was a side length of B. So we made a mark that is a length of B over here. And I'm going to use that to draw a triangle over here on the left, connecting with this top corner here. Okay, and then I'm also going to draw connecting to this top right corner over here with that same point. Okay. So now we're going to do some labeling on this. So here's our figure again. Still our A squared plus B squared, our blue and our pink squares. Now let's look at our triangles. So our triangles have a side length of A over here, because that's the side of our blue square. B right here, because when we folded this over, we made sure to make a mark that was the same length as our pink square. B right here, because that's the side length of our pink square. And then this side, for this triangle over here, is a side length of A. And I know that because originally this distance right here was A, because that's how long our blue square's side is. And this side length was B, because that's how long our pink square is. And we essentially just swapped the places that they were in, and we moved our B portion over here and our A portion over here. And what else I know about these two triangles is that they're right triangles, because these were originally, or these are squares, and I know that there's right angles there. So with this information, I know that since my leg lengths in these two triangles are the same, A and B, and they both have a right angle, they're right triangles, these two triangles are the same size. So they have a third side to them, which I'm going to label as C. And because those two triangles are the exact same size, I get to label this side length C over here as well. Okay, so all three sides in the two triangles are the same, and their angles are the same as well. So they are congruent triangles. What's really important is that we recognize that these two sides are both of length C, since the two triangles are congruent, meaning the exact same. So now I'm going to take my figure and I'm going to do some cutting of my figure. Again, my original figure is still A squared plus B squared. I'm just going to rearrange some pieces now. So I'm going to take this triangle piece off and this triangle piece off. Okay, so here's my original figure. And I'm going to rearrange. So I'm going to take this triangular piece, which still, remember, this side length is still C. Okay, and I'm going to rotate it, and I'm going to put it up here. So now that side length of C is over here as well. This is still a side length of C. And I'm going to take this triangle. Again, this is a side length of C. And I'm going to rotate it. And I'm going to put it over here. And now that same side length of C that was connected right here is happening here. So what we've done is we've taken that same amount of space that was originally in my blue and my pink triangle, or excuse me, my blue and my pink squares. And we've used that space and rearranged it, and we've created a new square. This new square has 4 side lengths that are all C. So that means when I do C times C, side length times side length, to find its area, the area of this new figure is now C squared. And I know that because I didn't take away or add any additional area to my original figure, that the original figure, my blue and my pink square that were A squared plus B squared for those areas, are equal to the same area. It's just a different square now, but the area is the same. And this area is now C squared. So this proves that A squared plus B squared will always be equal to C squared. How awesome is that? So cool. Have a wonderful day.